Hey there, all the tech geeks, all the coders out there. This is your innovative coder, and in this video, we'll be talking something about transfer learning. I know last video and this video are like quite different from other videos I was posting until now. They were the basic hands-on on Python, and then I thought of going on to machine learning, but for as of now, I am telling about these projects. So bear with me. Like if you don't know about all of these things, then you can take it as a motivation. Like in future you'll be doing these projects only. Um, so let's start with this. So this is basically a transfer learning project. And what is transfer learning, and why is it needed, and why is it necessary, and why I'm so mad about this thing, you'll get to know in a minute. So what we do over here is, basically this project focuses on something known as classification algorithm. Classification, this is a classification problem. Basically we are classifying a set of humans and a set of dogs. We what we are doing is we are classifying that if in a picture we have a human or we have a dog. If it is a human, then it will just print that hey human, and if it is a dog, then it will tell the breed of the dog. So like we have 133 breeds in a data set, and we'll be training our model on that thing. So what we are doing is, firstly we are importing the dataset. SQL datasets we are using to load the file. Then keras, which is a popular machine learning framework. So guys, there are like three most popular framework: keras, uh, theano, tensorflow, and pytorch also. So like these are very three or four very popular framework, cafe, and like all of that stuff. So I'm using keras, which is quite easy to understand. Then numpy, which is the basic library of machine learning. Glob, cv2, opencv, matplotlib to plot the images and graphs. And then I don't know why I'm again importing numpy, so that's okay. Then we make a function load dataset. I'm giving the path to that function. We are loading the dataset, all of this thing, and then we are returning the doc files and the targets, which is the y. Then we are loading the dataset. Images training images loaded, validation set loaded, testing images loaded. Now what we are doing is we are printing the number of total dogs. We are printing the dog images. We have the number of dog images in the training, validation, and test set. Now what we are doing is we are like what we have over here is we are taking some random number, but we are specifying this random number to like control the randomness. Like we are creating the randomness and then we are controlling it. You'll get to know this thing, like why do we shuffle and all of that stuff. Like here we are doing random dot shuffle. So why we are doing this, I'll tell you in a moment. Okay, so we have over like 13,000 total human images in our dataset. So it was quite a huge dataset, right? Now what we are using over here is to detect humans is something very basic and like very niche approach. What it is actually, what it actually is. Um, yep, what it actually is, like we have OpenCV, and we use har cascade classifier. So these are like some set of XML files, and we load the files, and then we apply that to our image, and it detects the face. Like here I'm giving the frontal face har cascade classifier. So what it will do is it will detect the face, but here it is giving me error. So number of faces detected is 0 because I uploaded an image which was like, you can see that this image is like quite hard to classify, or it's very hard to detect the face over here. And one thing also, like OpenCV doesn't work when you are wearing spectacles. So maybe that is the case over here. So yeah, so this is basic stuff. This is basic stuff. I haven't used a CNN for you know for recognizing the face, for detecting the face, but you can do that. You can do that. That's like a much higher approach than what I have done over here. Um, yep. Then we have like importing the files and then sorting them and doing all that stuff. Like now we are detecting the humans. So number of humans detected in humans is 100, and number of humans detected in dogs is 12. So like we know we can see over here like how bad our classifier is working. So there is some, like I have written uh, my analysis report. I don't think that this is a reasonable expectation to pose on the user, as user could be standing facing camera from 0 to 2 pi radians, hence not a good algorithm. Even if the face is not visible, algorithm should be able to find out the image containing a human. I think we can use deep learning to identify the image contains a human or not. This algorithm is just concentrating on face detection, on not on humans, and not even considering 0 to pi radians. I feel the face detection should at least consider 0 to pi radians, and this could be easily attained by deep learning, what I told you earlier. Now what we are doing is we are detecting the dogs. So what we are using over here is something known as ResNet 50 model. So why I am using this, bear with me, we'll understand this in a minute. Then we are using keras.preprocessing, TQDM. TQDM is a library to have these when we load the model, we can see like what percentage of model is being loaded. So okay, yep. So now what we have is keras.preprocessing, now path to tensor. So what we are doing over here is we are resizing our image to load into the model. We are resizing our image to 224 cross 224 dimensions, to a 3D tensor, which has three channels: the RGB, red, green, and blue. Yeah, RGB, red, green, and blue. So we are loading those. We are resizing the images, and we are loading the tensors into our model, basically into our image currently. Yep. We are now what we are doing is we are making an array of images, and now we are giving the path to the tensors. So we load the images. Now we sort all the images, and we give it to our model. So these are functions. We'll be calling them at the later stage. Okay. Yep. Uh, I think this has become a very long video. So we'll be continuing the session later. Let's just stop it over here.